First I want to talk about is a technology called BIM. Now what that acronym really associates with is this discipline called AEC. It's Architecture, Engineering, and Construction. The device that you're seeing on the screen is, we'll call it a boiler or a heat exchanger, but it's fairly compartmentalized in size. However, this heat exchanger is going to go into a large facility, factory, stadium, something extremely large. And that's what these BIM products, or these AEC software products like Autodesk Revit, are actually designed for, is ridiculously large-sized facilities. So what happens with all of this is we build the models in your CAD tool with all the detail that you need. Now this detail is fantastic to build because you're going to need to know where the fasteners and the lifting lugs and all of the other components happen to be. But when you're looking at a stadium with 20,000 seats or a large factory that covers several football fields, this kind of detail will be devastating to your performance. So we want to set these files up so that they have a lot higher performance, but they still fit the bill for what they need to represent. Because when you're looking at it like this, the detail is necessary. But when you're looking at it like this, the video card is taking the hit, but you don't need those hex head bolts. In fact, there's hundreds in this part that are going to just kill your video performance. So under your Tools pull-down menu, next to D feature, which is a lot of what AEC actually does, but it's called Export to AEC, Architecture, Engineering, and Construction. It runs you through a process here. Now, the first part here is orientation, and the reason this exists is because we are based on the Parasolid modeling kernel. And when you export to an AEC product, Autodesk Revit we'll use as the example, they are generally based on the SAT, the ACES kernel. And ACES defaults to the top plane, like you're looking at the Earth, which is a lot of what 2D architectural civil engineering products do. However, our Parasolid modeling kernel-based products like SOLIDWORKS and Solid Edge and Unigraphics, they all default to the front plane. So when we export this file as is, as a SAT file or ACES file, it actually goes into the other products on its side. So the first thing we're going to do is orient this based on floor, ceiling, or wall, whatever this is going to sit on. And we'll just do that by simply picking the bottom of this foot, and that's going to be the floor. And then we'll just give it a datum, lower left-hand corner, origin of 0. 0, 0, 0. The next step it runs you through is the model quality. And you can choose some defaults of high, medium, or low, but if you trigger custom, what's going to happen here is it runs you through the D feature tool. Now the D feature tool allows you to automatically remove internal components, and if you can't see them or see them mostly, even though this has a hole in it, some of these parts are deemed internal because the camera points around this assembly. Many of them cannot see these parts, which would make them an internal qualified part. But you can also just say simply small parts, a particular percentage of the overall size of this assembly, or even combinations where physically selected parts like this handle don't need to be there. When we go ahead and take this and update by removing the things I've selected, so parts that are less than 6% of the overall size, and then part specifically selected, it will scrub those off the screen for us. So what D feature also is useful for is actually removing internal details that are maybe difficult to remove with things like suppressing features or extruding over top of features to conceal internal details. D feature is something you'll want to try if you do want to send files out, but scrub some proprietary information from those. So here it's removed a lot of things. I got rid of the handle I selected. You can see that all the heads of those fasteners are gone. And when we select Next now what we're going to get is a choice of features to keep. Now this would be things that are critical. In this case, I'm actually going to select the holes in the mounting feet because those holes are going to be bolted to the floor, and regardless of what this is, I want that hole pattern to be useful downstream. Now when we say go, it will take the criteria and remove everything else insignificant. So it's going to take features out of parts, it's going to take parts out of the assembly, and the result of which is going to be what you see on the right-hand side here. So first thing is it's on its side, which in an AEC product is actually the right orientation for it. It would actually roll around and be on its end. The second thing is you can see a lot of the internal detail that's been removed. As I roll this around, there's a lot of parts that are gone. Most of the stuff that's up on the inside is gone. Not everything's there. But the fastener holes over here on the side are completely removed as well, even the holes inside these lifting lugs. So you can see exactly what the results of this tool are. Now if I click Next, my choice is to save this as an ACES model, which again is the file choice of type for Autodesk Revit and other AEC products. And I won't continue with that. But the idea here is to prep your files for consuming downstream in these larger scale but less detail specific applications.